Have you ever stopped to think about the sheer complexity of what happens when you type a URL and hit enter? It's a process that involves global infrastructure, multiple layers of networking, and high-speed communication, all occurring in less than a second. It all starts right here, in your browser. As you type those characters, the browser is already preparing for a journey. It needs to translate that human-readable name into a machine-readable IP address. This is the first step of a multi-stage marathon. In the next few minutes, we are going to break down every single hop, from the initial keystroke to the final pixel being rendered on your screen. We'll look at DNS lookups, TCP handshakes, and how your browser builds a website from scratch. Let's dive into the hidden world of web requests and see the magic of the modern internet.
Before the browser goes out to the internet, it checks its own memory. This is called caching. The browser maintains a repository of previous DNS lookups to save time. If you visited the site recently, the IP address might already be there. If not, it checks the operating system cache and even your router's cache. It's like checking your own contact list before calling directory assistance. Each of these steps is designed to minimize latency. If the address is found in any of these local phone books, the process skips the long trip to the DNS servers and moves straight to establishing a connection. But if the cache is empty, the browser must prepare for a more formal inquiry. It's a hierarchy of efficiency, ensuring that the most frequent destinations are always just a microsecond away from being reached.
If the address isn't in your cache, your computer reaches out to a DNS recursive resolver. Think of this as a librarian who knows where every book in the world is kept. The resolver doesn't know the address yet, so it asks the root name server. The root server doesn't know either, but it knows where the .com top-level domain server is. The resolver then travels to the TLD server, which directs it to the authoritative name server for the specific domain you're looking for. Finally, this server provides the IP address, like 142.250.190.46. This recursive process might seem slow, but it happens across the globe in milliseconds. Your computer finally has the destination address it needs to start a real conversation with the server. It's the ultimate directory service, making the human-friendly internet possible.
With the IP address in hand, your browser needs to establish a connection. It uses the Transmission Control Protocol, or TCP, to ensure data is sent reliably. This starts with the three-way handshake. First, your computer sends a SYN packet to the server, which stands for synchronize. The server, if available, responds with a SYN ACK packet, acknowledging the request and asking to synchronize back. Finally, your computer sends an ACK packet back to the server. Now a secure, reliable connection is established. It's like two people agreeing on how they will talk before they start sharing secrets. This handshake ensures that both the sender and the receiver are ready, and that they can track the pieces of data that will soon be flying back and forth across the network.
Since most of the web now uses HTTPS, the next step is the TLS handshake. This is what puts the S in HTTPS, standing for secure. During this phase, the client and server exchange certificates to verify their identity. They use asymmetric encryption to safely agree on a shared session key. This key will be used to encrypt all the data that follows, protecting it from hackers or snoopers. Imagine it like a secret handshake that also produces a unique one-time use lock-in key for a private conversation. Your browser checks if the server certificate was issued by a trusted authority. If everything checks out, a green padlock appears in your address bar. This process ensures that your passwords, credit card numbers, and personal data remain private as they travel through the public internet infrastructure.
Now that the secure pipe is ready, the browser finally sends an HTTP request. This is usually a GET request, essentially saying, "Hey, please give me the contents of the homepage." This request contains more than just the URL. It includes headers, which tell the server what kind of browser you're using, what languages you prefer, and whether you have any cookies stored for this site. Cookies are like digital ID cards that help the server recognize you, perhaps keeping you logged in or remembering your shopping cart. This small packet of data is the formal order form for the website. It travels through routers and switches, crossing oceans through undersea fiber optic cables, until it reaches the specific data center where the server lives. It's the moment the server finally learns exactly what the user wants.
Upon receiving the request, the server springs into action.
This is the back-end processing phase. The web server, like Apache or Nginx, passes the request to a web application. This application might talk to a database to fetch your profile info, run some complex logic, or pull images from a storage bucket. It's like a chef in a kitchen receiving an order and gathering all the ingredients to cook a meal. The server doesn't just have the page sitting there as a single file. It often constructs the page dynamically for you. Once the application has gathered everything, it packages it all back into an HTTP response. This response will contain the HTML code, which is the skeleton of the web page, along with instructions on what other resources the browser will need to download next, like CSS and JavaScript. The server sends back its response, starting with the status code. You've likely seen 404 not found before, but in a successful request, the server sends a 200 OK. This is the green light for your browser. Along with this code comes the actual data, the HTML. As the browser receives these packets of data, it starts to reassemble them. But the job isn't done yet. The HTML usually references other files, CSS for styling, JavaScript for interactivity, and images for visuals. Your browser sees these references and immediately starts the whole process over again for each file, opening new connections to fetch every piece of the puzzle. It's a massive parallel operation, grabbing dozens of files simultaneously to make sure the page loads as fast as possible for the user.
Now the browser enters the rendering phase. It parses the HTML to create the document object model, or DOM. This is a tree-like structure representing every element on the page. Simultaneously, it parses the CSS to create the CSSOM. The browser then combines these two into a render tree. This tree tells the browser exactly what needs to be visible on the screen and where. Next is the layout phase, where the browser calculates the exact coordinates and size of every box on the page. Finally, the paint phase occurs, where the browser fills in pixels, colors, text, and images onto your screen. This entire process from parsing to painting happens dozens of times a second if the page is moving or changing. It's the final step in turning raw code into a beautiful interactive interface.
And there you have it. In the time it took you to blink, your browser looked up an address, shook hands with a server across the world, secured a private connection, ordered a page, and painted it pixel by pixel. The internet is a marvel of engineering, a global collaboration of hardware and software working in perfect harmony. Next time you hit enter, remember the silent, lightning-fast journey your data is taking. From DNS to the final render, every step is a testament to how far we've come in connecting the world. If you found this breakdown helpful, don't forget to like and subscribe for more deep dives into the technology that powers our daily lives. Thanks for watching, and happy browsing.